Okay, so here we go.
64.
64 factorial divided by this quantity,
32 factorial.
32 factorial,
Over.
times 64
64 to
to
the
the
32.
32nd power.
Which is going to be.
All right, let's see what Wolfram and Alpha says about that. There's the number. So 0.0000.
So it's
Is
pretty
that 4 zeros and a 7?
Yeah, 4 zeros.
That's pretty small.
So it's about 7 over 10,000. Or 7 over 100,000.
7 over 100,000. Yeah. No zeros is 1/10.
Yeah.
Right? Then 1/100th, 1/1000,
One.
1/10,000. So this is like 7.68 over 100,000. So let's call it 8 over 100,000.
All right.
So if you did your game 100,000 times,
You get this 8.
you'd only expect to have been successful 8 times.
Would that take like a lifetime or something?
Well, how long would it? You would expect it to take 100,000 divided by 8 times on average to get it once.
So
Yeah.
we could do 1,000.
100,000 divided by 8. Now you should be able to do this in your head. What's 100,000 divided by 10?
It's 100,000 divided by 10 is 10,000.
Okay. So what's 100,000 divided by 8? Do you think?
Well,
1,000 divided by 2 is
is it-
50,000. Divided by 2 is 25,000.
well, isn't it? Well, 8 divided 1,000 divided by 8 is 125.
1,000 divided by 8 is 125.
So this is you just have to add 2 zeros onto that.
So 1,000. It would be 12,500.
Very good. 12,500. Let's just double check if Wolfram Alpha agrees with us.
12,500.
12,500. Okay. So, another interesting question. I said it was related to something called the birthday problem.
Yeah.
The birthday problem is this. The question is, how many people do you need in a room so that you have a 50-50 chance that 2 people have the same birthday?
Wow.
Okay, and not the same day, not the same day and year, just the same day. So like, whatever, July 4th. 2 people have some random 2 people have the same birthday. So you have to do the same calculation as we were just doing. So when the first person walks into the room, you've got 365 over 365. There's only one person in the room. They're not going to have the same birthday. The second person to miss is going to be 364 over 365.
Yeah.
So it's related.
The third person to miss. So we're going to calculate how do you miss always, and we're going to see when you get below 50%.
Yeah.
All right.
Okay, so we keep adding. So we would do 365 factorial on the top.
That's even bigger than 64 factorial.
Yeah, it'd be interesting to see if Wolfram Alpha can do this. And then however many we're doing, how many we're chopping off. Let's say we did. Let's say we did 10 trials. We would need to have 355 on the bottom, and then we would do 365
Times.
to the 10th.
What you put?
Oh.
Yeah, you put that.
Do you see what I'm doing? I have 3. This would leave me with 365 divided by 355 factorial would leave me with 365, 364, 363, 362, and then I would always have 365 on the bottom, so that's why I got the 10th. So here's the probability of everybody missing each other when you walk in.
0 point. It's a little.
88%.
So,
So with 10 people, we see we only have about a 12% chance of having an overlap. Okay?
Not nice.
What's the next number you'd want to check?
well, how about 20?
Okay. So 365 factorial is going to stay on the top. What am I going to have on the bottom?
365. 345 factorial.
345 factorial
Times 365 to the 20.
to the 20th. Okay.
Let's see what we got.
Okay.
What's
So
it-
with there, it's about call it 58.8% or 59%. So with 20 people in the room, there's a 59% chance that everybody
So
misses.
Our percent increased a little.
The
Or decrease.
what is our percent? What's the probability that we have a match?
Well, it's gonna be 41%.
About 41%.
So we should try 30, or
Well,
maybe
maybe
25.
25. Okay. So what am I? I'm going to have 365 on the top. What am I going to have on the bottom?
340.
340.
340 and then 365 times 25.
Okay.
Let's see. 0.43.
43.
So
So now, what percent chance do I have of a match with 25 people?
you have 57%.
Oh, so with 25 people in a room, there's more than a 50% chance it's two
So
people
we've
have
got
the
to
same.
go lower.
Okay, so it's somewhere between 20 and 25. What do you want to try?
23.
23. Okay, so
We
we're
can't
gonna
do half people.
we're gonna add 3 to this. Sorry, we're gonna add 2 to it because we're subtracting away
Yeah.
23
23.
and 23.
What?
There you go.
0.492. So really
That's
close.
basically it.
That's basically it. You need 23 people in a room. Isn't that amazing?
Yeah.
So you're in a room with 23 people or more, lots of times. So if you're ever in a room with 23 people,
Someone probably has the same birthday as you.
there's a better than 50% chance. Not as you. You got to be
But
careful. That
as
2
someone.
people have the same birthday.
As someone else.
Right. It's not that someone has the same birthday as you.
Someone
It's that
Two
2 out of the 23
That
people.
might be an interesting problem. If you have a birthday, what's the probability that someone has a birthday the same as you?
Yeah, maybe we'll do that tomorrow. Extend our birthday discussion. All right. High five, guys. Good questions on Othello. Fun little diversion into the birthday problem. Good job.